The essence of today's webinar is to talk about codes, how to test the codes, and also how to deploy. And I'm tagging it becoming a full stack developer because the moment you know how to write codes and ship this code, more like deploying these codes, it, it becomes a software. And the person who can do that is actually a software developer. And the full stack in it simply means you can do both sides of this software, meaning the front end and the back end. So that's what they mean by becoming a full stack developer. A full stack developer is somebody who can actually write codes for the front end and also write code for the back end and push the two of them to become one software application. So my name is David Sampson, and I'm a full stack engineer, and I've built a couple of softwares, and I also teach coding. So apart from um, my own job experiences, I also teach and I also mentor too. So I teach both front end and I also teach back end too. So what is full stack development? Now, I want to believe that if you are to write codes, that it is either you are writing that code for front end or you are writing it for back end. But I'm taking full stack as a whole, the whole thing. Um, if you write a front end application, now most websites can actually run simply as front end websites. That's the difference where you have a website and a web application. They are both not the same thing, but a web application requires both sides, both the front end and the back end. So you build what the people can see, and you also build the logic behind the scene. That is the back end. So the front end is what we refer to as the client side, the visible part of the website. You can build it with HTML, CSS, and JavaScript. And sometimes you could also use frameworks like React, Vue, and Angular. Now, this is for people who want to write codes. But there are also people who build a website without writing codes. That exists too. So, but for us, we're talking about building it with codes. Now, for people who do it without code, they had a little limitations as of now. But for us, if you write codes, there is absolutely no limitations to it. So the back side of it is the back end, the server side, the part that handles the entire logic, the database, the authentication, the Node.js. Now, a typical example of how this would work is possibly if you want to sign up on Instagram. If you want to sign up on Instagram, you go to the sign up form. You are seeing the form that is asking you for your name, email, phone number, whatever details they require. And you also get to see the ones that are compulsory and the ones that are not compulsory. So as a developer, you have the choice of setting will I say requirements for that form. So if somebody wants to do something, there are certain fields that are required. So the developer does that. And the reason for that is because on the back end, he wants to process your sign up and he requires certain information. For example, the email. Now, email is required. And the reason why it's required is because you want to be able to identify each user with that particular email. You can also make phone numbers required. And these details that are required are supposed to be unique, meaning that no two persons can share the same maybe email or phone numbers, or if you're going with NIN or even BVN. So there are information that are required and are supposed to be unique. So these are information that on the front end, you don't really do much with it, but on the back end, you require it and you use the logic to make sure that these things are unique and no other person has the same information. But for the names, they can be the same names, they can be the same location, they can be the same username and whatever, but there are certain part of it that you want to be unique. And the next part is the database. After you process the whole logic and you confirm that this user is authentic, you'd want to save that information on the database. You save the information on the database and then send the person a success message and telling the person successful, you've been able to register correctly. So that's like a typical example. Another example would be for those who use maybe OPay, PalmPay, and all of that. You may want to, of course, the same sign up or sign in that works for Instagram will also work for maybe OPay and MoneyPoint. But the difference now is they've also upgraded it a little by adding fingerprint. So some person get to log in with fingerprint, and that this is the reason why coding it is very, very important because each day users' requirements are getting, will I say, it's growing. What people wanted last week or maybe last month or last year is actually not what they need right now. There are people who I'm sure since this year they've not stepped their foot in any bank. But these same people, last 2 years or last 3 years, we are always in the bank. My transaction failed. Oh, I want to open account. Oh, customer care. So, but because the demand for what people are asking for is now growing, so like call them softwares or fintechs like OP, MoneyPoint, and all of them are coming up, bringing out those required, will I call desired functionalities that we want. And in the nearest future, those things may actually not be what we want again. We're going to need more. So, as a developer, whenever you are writing your code, most times just have at the back of your mind that users' needs they evolve, they change regularly. So as a user, as person who is writing the backend code, the first thing you want to do is make sure that your front end is actually aligning with the backend. For example, whatever you are asking the user for on the front end, it is clearly written there. It is there. And before I go much, you don't write codes without knowing what the design was actually is. So I know that a design person is not here, but before you start building anything first, you have to see what it looks like. And that is how you can actually judge if I'm getting it right or not. That's how you get it if I'm getting it right or not. So sorry for that disruption. Okay, so continue. And the first part of it is the codes. And so when you get the design, how it should look like, because that is the basis of which you can judge yourself. And not only you, like all the project manager, the project owner, and so on and so forth, they will judge what you are writing, the codes you are writing, based on the design that was given to you. So you take a design and you write codes for the front end, and you can either use React, which I do, and that is why you are seeing React component here, because I write with React JS. Now, React JS is purely a JavaScript library, which if you work with the front end, you're going to learn a React library. And these components, you build them together, even though they have HTML and CSS underneath them, but you're building it with React, and you connect APIs to it. APIs are simply, will I say, messengers that the backend developer gives to you to attach to each of your components, whether it is a form, whether it's a button, whatever it is. As the user is interacting with these components, they are calling the messengers that is actually sending a message to the backend. So you write your front end and you see that your front end is good, then you move to the backend. You build certain APIs. Of course, you would have built an API that you'll be sending to the front end developer. If you are the person building it alone, you can do either one first, the same way. So you build your RESTful API with Express, and that is why, and the reason why I'm writing Express here is because I write my own APIs with Express, but a lot of other developers, they write theirs with so many things. And when it comes to coding, there is, I would say there are three different ways of doing a particular thing. So the way I'm doing it may not actually be the way another developer wants to do it. Now, it doesn't mean that any one of us is wrong. It simply means that that is how we choose to do it. I choose to do it like this, and that's how I want to do it. So there's actually no best and perfect way of writing your code. The most important thing is that it works, because at the end of the day, the users are not judging you based on the code. Now, except for people who are reviewing your codes, but except for those ones, nobody cares what the code looks like. They want to be sure that everything is working maximally. That is where they will judge you. So the second thing is setting up the data, or the third thing, setting up your database. And I wrote MongoDB database. There are different kind of database, and you can choose from any one of them. But I use MongoDB a lot, and that is why I'm putting MongoDB here. But before you start writing code, you would have set up your environment. Maybe you install VS Code. You'll be using VS Code tools. You have Node.js. You also have access to MongoDB Atlas, which is the database, and also Postman. So here I say, think of a full stack developer as someone who can build a house from the design, the point where they've given you a design, how it should look like, to the plumbing, which is like the last thing, the last part of the whole house before it becomes useful. So the next thing is the testing. When you are done building, now most persons deploy the applications without testing it, and at some point it breaks. Sometimes it doesn't, but either ways, to be on the safer side, it's advisable you test everything you build, every code you write, every single line you test it. You can do manual testing, maybe clicking on the application, clicking different buttons, and checking out every form to see that they are working. Or if you are testing the backend, you can use Postman to test your backend in the parts where you don't get to see them. That's a manual testing. And you can do automated testing too. Like you write short script to test your particular functions. And for backend, we can use Jest testing or React testing library to test for the front end. It works. And also, if you encounter issues and debugging, I like using console logs to check out for any errors where that most times if I maybe I don't even know what is going on, but I use console log to log a message. Sometimes the message may make sense, sometimes it doesn't make sense, but I just want to see if every line is working. If every line is working, and if every line is working, for me that's okay, and that's enough. So the next part will be deploying. Now, this application, you're going to be starting from the design. It takes time. It takes time. Some applications might take you 3 to 6 weeks. Some can take you 1 month to even 6 months. Some can even take years to complete, depending on the functionalities. So as a backend, or maybe as a full stack developer, maybe front end or back end, the most important thing to look out for is what are the key functionalities to build on this application. But of course, you need to write them down. When you write them down, you also need to go through them with whoever is in charge, maybe the CTO or the project manager, whoever is in charge, to make sure that the particular functionalities that you have are actually what they are asking for. Most times what you understand from the project may actually not be what they are asking you to do. And by the time you get to deployment, you then discover that, oh, you have to go back and do it again. Because until you deploy, most times they don't get to see it, they don't get to test it on their own application or on their own devices until you deploy it. So before you actually start, make sure you confirm with the functionalities that you are supposed to build into it. And by the time you get to deployment, there are so many tools or so many, like call them applications or servers that you can use to deploy. If it's for front end, I put Vercel here because I use Vercel a lot. But there is Netlify, there is Render, and there's Heroku. There are so many places you can deploy a front end application. But for Vercel, Vercel is also free. So as a learner, or would I say as a beginner, no matter how would I call it small or large that your application may be, you can actually host it for free on Vercel. Even though it gets larger, you can still host it for free while you are still developing. So when you are done developing, whoever is the owner of the project or the company, they will have to pay for a hosting account. And the same thing for backend. Now, most times you can host these two applications on the same server. Most times, if you're a full stack developer, you can host both of them on the same server, say maybe on Heroku or maybe on Render, anyone you want to use. But in other cases, you may want to host them differently. That is, if you are building both of them differently, you want to host this one in a different server and you host this other one in a different server. So for the backend, you can host it on Railway, Render, Cyclic, Heroku, AWS, DigitalOcean, as the case may be. But most of them are not free. Yeah, but I use Render if I want to host a free application. I also use Cyclic because Cyclic allows me to host Node.js application. So, and it's also free. So as a newbie who is starting, you can write your simple applications and you host them on these servers and they're free. But when you are done, you want to get a paid account, maybe on AWS or Heroku or even on Render, and your applications runs down. The reason why you need to get a paid account is because most of these servers cost money to run, and they are supposed to run every day non-stop 247. So, but because it costs them money to run and they are giving it to you for free, most times your server will be sleeping, meaning it will, like say, it becomes inactive. And at what point, one is inactive, if a user tries to make a request to it, or you try to make a request to it, it will take it a while to wake up and then process that request. So because it's a free account, most times there will be delays and there will be slow, it will be very slow. But that's okay if you are still developing. The moment you are done with development, you can then get a paid account and deploy your backend. And for database, I use MongoDB Atlas, but there are so many places where you can host the MongoDB application and it will work perfectly and fine for you. And now, if you want to deploy a project, typically you want to learn how to push your code to GitHub. That is one important thing. There is no developer without a GitHub account. Now, even though there are other places where you can push your codes to, but GitHub is a very popular application that people use to maybe organize code for version controls and also to work with other developers. There are a lot of persons who I work with. I haven't met them in person. And we share codes. We work on different versions of the codes using GitHub. So the first thing, or maybe not the first thing, but one thing we want to learn is how to use GitHub. Because as a developer, you'll be pushing your codes to GitHub. And if you also want to deploy, the first aspect too might be to push to GitHub. If you are following this approach, of maybe deploying to Vercel or Render, you will have to push it to GitHub. But if there's any other, about for other deployment servers, there are different ways to do it. But these ones, the Vercel and the Render, you need to first push your code to GitHub, then connect your Vercel or your Render to your GitHub account. Now, the Vercel is for the front end, while the Render is for the back end. So you connect the two of them to your separate GitHub repositories and then configure your environment variables. For example, if you're using your MongoDB URL, your password, your emails, your tokens, as the case may be, all those variables, secrets that runs your backend, because believe it or not, there are informations on the backend that when they are released, your backend become prone to attack. So these information, they are called environment variables. They are secrets, things that nobody is supposed to see. It could mean the login access to your database. It could be NIN. It could be accounts. So many things that connect to your application. And then finally, you hit deploy. So it's as easy as that. I know I'm not doing it here, but it's as easy as that. If you are enrolled, it doesn't take a day to learn how to push maybe your front end application and deploy it, and also push your back end application and deploy it. Now, even though there could be, will I call it, sophisticated ways of doing this, but doing it this way works perfectly. It doesn't take anything away from you, and it doesn't mean that you don't have idea or how to do it sophisticatedly, but it works. And if it works, that is perfectly fine. So in conclusion, tech is for everyone. Start small, write your code, stay consistent, and keep learning. Now, as a developer, I started learning coding in 2016, and even on to date, I am still learning. I keep learning, I keep teaching, I keep learning, I keep teaching. So you find mentors, you find people who are good in the areas you want to go to, people that you can ask questions if you are encountering any bug or any challenge in your codes, people you can always reach out to, and communities that can also support you. So you can start today, start with Smart Hub. Thank you. I don't know if I'll be taking questions or if it's time for the second speaker. All right, guys. Bye.
Okay. Uh, okay. That is a fantastic one. That's a fantastic one. You guys should drop like a reaction now so he can feel himself soon. Okay. Okay, yes. You heard from him. You heard from him. The web, the software experts in general. So you heard from him. He started from the building phase, and from a developer point of view, what was I to say from a developer point of view, you can build and deploy for free, for free. And there's something that he highlighted. You can build without code, but for it to be that sustainable, you have to use code, and code is more sustainable, like he said. Then she shifted to the part whereby you have to deploy. You can deploy for free, but as he told you, the downside of deploying for free, sometimes your server might be sleeping when you want to when your user wants to trigger a good, assuming that you have like a fintech app and your user wants to trigger like a good source, a good revenue for you, and your server is sleeping, that is enough to like give the user a bad distance. But it's a good way to start. It's a good way to start. It's not every time you need to be sleeping, so it's a good way to start, and you can use that to create like something to pitch to investors, and investors will be mesmerized by the build and everything. He can further give you enough money to buy enough servers. So I'll make way for the second speaker, which is a cloud engineer expert, an expert for that matter. He does cloud computing, cloud engineering. He also does DevOps. So he will continue from the deployment aspect. I know the first speaker shared some things about the deployment, but he will take it from there, and he introduce more tools in the deploying aspect. So I'll just pass the mic over to him. And his name is Mr. Eze Amadi. Thank God, Amadi. So, Mr. Thank God, can you hear me?
Yeah, I can hear you loud and clear.
Okay,
Can you hear me?
I'll pass the mic to you so you can continue.
All right. Good evening, everyone. Welcome to this webinar. So I'll be taking you through when your application is ready, when you're done with your code, what do you do next, which is to deploy. So let me share my screen. Just let me know if you can see my screen so that I can proceed. All right, thank you. So code test deploy, a developer and cloud engineer guide to going live. Okay, so this topic, okay, exploring seamless collaboration across the development and operation team for reliable deployment. So I think initially, when initially back in the days, developers used to be on a separate team. Then when they are done with their code, they just package it and everything and give to the operations team. So the operations teams will now handle the deployment and bringing the application live for users to use. But as technology continues to grow, as they started bringing these two teams together, they no longer work in silos. So I think that's where um, cloud engineering started coming in. You now start hearing things about DevOps and everything there. So this has fostered a collaboration culture between the developers and cloud engineers, where a developer will be in his or her laptop and they are writing their codes. Once they just push their code to GitHub, automatically that their code is deployed live, and the users anywhere in the world can actually see those applications. So it's one of the good things that have come on board. So I'm Okwesiri Eze Amade, or you can also call me TG. So I'm a DevOps and a cloud engineer. I'm also a tutor. Yeah, I tutor people on our cloud engineering as well. So as I talked earlier, the modern developers workflow. So code test deploy. Our previous speaker talked more about the coding aspect. So I will focus more on the test and the deployment aspect of it. So for the code, here the developers write clean, production ready. So like as you have Facebook, WhatsApp, as you can use Facebook and WhatsApp and all those applications, the code that is running in those servers are production ready ones. So not the one like when you're coding, you're still testing, you're still checking if one or two are working. So it's different from the one that like the users have started using. So those ones are called production ready codes. So developers write clean, production ready, scalable codes with different programming languages. So they use different programming languages: JavaScript, Python, Java, C, C++, a lot of them out there. So they use this to create application that solves human needs. So when they are done with writing this application, remember you are going to be deploying it live. So it needs to undergo series of testing so that this application won't break in production. When I mean break, suddenly you visit, let's say facebook.com and it's not loading. So that is the application breaking. A lot of things can usually cause it, but when you carry out your testing, as a cloud engineer, when you carry out your testing, you'll be able to figure this out. So, and you refer back to the developers, okay, this place failed test, work on it. So that's how you continue to improve till you get a production ready code and you push finally to the environment that you've created that will host it. So the important testing that is to be done is we have unit testing, integration testing, end-to-end testing, and performance testing. So as I've broken them down a bit. So the unit testing, it tests for individual components functions, or you can say functions. So you might, a developer might write a function that does a particular thing. So that needs to be tested that is working. So a cloud engineer will set up, there are tools we use. So we use, I think in the next slide or in the next two slides, we'll talk about those tools. So a cloud engineer will use those tools to test. So if there is failure, will inform the developer, okay, these are the areas. So remember I talked about how as technology has advanced, there is more cooperation between the developers and the operations team. So this constant communication is always there. So the next testing is integration testing. So here I ensure different components work together, right? The first one is just testing for a function. The second one is 2 or 3 functions might be performing some series of tasks working together. So you need to test how they work together and make sure that they actually do. If it fails, you revert back to the developer, okay, this area failed, work on it. Then end-to-end testing is you are validating the entire workflow. Example, an e-commerce website where, example, you visit Jumia, where when you go to the homepage, you see products there, so you can select a product you want, add the product to cart, check out, pay, and everything. So that entire flow, you make sure that it's working. So that is end-to-end testing. Then performance testing, it assesses speed and scalability under load. So the emphasis there is under load. So okay, like I mentioned, the Jumia e-commerce, the e-commerce website, there are seasons where they have high people visiting their website, a high number of people visiting their website. Example, when they're doing Black Friday and all that. So that is load on its own. The number of people visiting the website increases. So you need to make sure your application and the server you are hosting this application can handle high loads. So this is where performance testing comes in. So this area is basically handled by the cloud engineer, because it's the cloud engineer that will create the server that the application will run on. So basically, if this place fails, the cloud engineer that will handle this area. So after the testing has been done and everything is okay, so the next thing is the code is now ready for production. So the code is then pushed to the hosting or deployment environment. So there are lots of them. Like our former speaker mentioned, we have AWS, that is Amazon Web Services, Google Cloud, GCP, Google Cloud Platform. We have Azure, Microsoft Azure. Those are the 3 big ones. Then we have smaller ones, like he mentioned Vercel, Netlify. I think he mentioned Cyclic or so that he uses. Those are ones that are smaller ones. Those ones you can host your application that is small. Like you have a blog app, a to-do list app, all those small application that doesn't handle lots of users or just solves a particular issue. Yeah. So like a website like an e-commerce website where you have user side, vendor side, probably an admin side. Then you have backends to serving this front end. So that application is a large one. You might want to move it to a bigger cloud platform like the AWS, GCP, and Azure to help you handle the big workflows and all that. But if your application is small and everything, probably a hotel approaches you as a developer, say, okay, just build an application for us to handle users booking and everything. It's not really that large, so you just you can just use those small applications. I think I might be fast a bit. So from code to deployment, the automation way. So these things I mentioned, the test and the deployment, you can do them manually, but it's going to take a lot of time. So remember, this test, you do one test and it fails. You tell the developer to work on it, and the next test you're doing them manually, it's very time consuming. So we, the cloud engineer, we automate this process. Automate means on its own. Once the developer pushes the code, it runs on its own. If it fails, it sends this developer back the message that, okay, this has failed, work on, and with a message that why it failed and all that. So let me walk you through how from code to deployment, how it is. So the first ones you have, number one is you plan, which are the project requirements, features, roadmap, what the project entails. You generate your PRDs, that is project requirement documents, and everything, including the design. Like our former speaker said, you can't code, not that you can't code, but you always follow a design pattern that has already been done by a product designer. So after that, the second one is the code. You write the code according to the plan. Then the third one is the build. So you build this code into, there are two major ways to build it. You build it into a Docker image. This is what you do as a cloud engineer, or you just compile it and push it to the server. Like all programming languages have a package manager. Like for JavaScript is npm, for Django is pip. So this can build the application. That means optimize it and make it production ready too. And you can still push it to your deployment environment. So then test is the one we talked earlier. So you automate the test to ensure the build meets quality standards. Yeah. So the fifth one is release. So this release is you deploy, if you build this application into a Docker image, so you need to save it somewhere, probably Docker Hub or other registries. So this package software is now stored somewhere. That's the release stage. Then the deploy, from that where you saved the Docker image, you pull it from there. Then you run it in your server. We always call those servers the deployment environment. So you run it in your servers. Then operate is you continue to watch it, continue to monitor it, to make sure that it's always on, it's always online. If your application goes down immediately, you are there to always bring it up, which is why for the Facebook is down, is the cloud engineers, they will go, okay, why is it down, bring it up and all that. So they normally have some metrics they use. Like one of them is MTTR, mean time to recovery. So all these are set. Mean time to recovery is when the application goes down, what is the time needed to bring it back on? Is it 2 minutes? Is it 5 minutes? Is it 10 minutes? Is it 1 hour? And all that. So all this will be defined before your application is being pushed. So let's go to talk about the tools proper. So these tools, you are working through them. I walk you through them from GitHub. Obviously, before it reaches GitHub, it goes from the developer's PC, their local PC, then it goes to GitHub. I believe the former speaker have talked about GitHub. So from GitHub, as a cloud engineer, you set up what they call a CI/CD pipeline. So CI/CD is a continuous integration and continuous deployment. So that's what it does. It's continuous, it's automated. It doesn't stop. You don't need to do it manually. Once they notice a change to the GitHub, this CI/CD pipeline picks the CI/CD pipeline or CI/CD tool picks it up. So there are so many tools. The standard one is Jenkins, but there are GitHub Actions, there are CircleCI and other ones. So The next thing is we use SonarQube for most of these tests. Remember the test I mentioned here. So the next two is SonarQube. We use it to run most of all this testing, code analysis, code smells, and everything. Then if it passes, I think this scan is part of this SonarQube too. So the next thing is Terraform. So we call Terraform an infrastructure as a code. Normally, I told you earlier that as a cloud engineer, you don't do things manually, you automate them. So platforms like AWS, you go there, you create your server, you click, and all that, and you create your server. But what this tool does is it just writes what you want to create. If there's one server you want to create, you write it in a script and just save it in this and just save it in this Terraform file. So once this Jenkins start running and it passes this test, it pulls everything in this Terraform and creates the infrastructure for you, which is here on AWS. Let's say it's an S3 bucket and EC2 that you want to create. And EC2 is the server we are talking about. So it pulls it here and creates. It goes through this process of Terraform init, plan, and Terraform apply. So it creates this. It creates this. So this other ones is the one you create prior. So what it does is save states. So let's say you're not the only cloud engineer in the team. You have another cloud engineer. So you've done something. And the other cloud engineer puts this your Terraform script. So the person start working on it, he needs to remember where you stop. So that's where this database is important. Use it to save it. Then after that, I talked about building your code into a Docker image. So that Docker image is saved in a Docker Hub, right? So after you build the Docker image, you save it to a Docker Hub. All these are automated. You write all the scripts and it happens. After it has been saved to a Docker Hub, it's now being pushed to the hosting environment or the deployment environment, which is S3 or EC2. Then from there, with your laptop, you can now visit your website. So the next thing you need to do is observability, like monitoring. Remember when I said this last part? This number, yes. Okay, this number 8. My monitor software performance. I hope you guys can hear me. So you use you scrape three types of data from your application. You scrape metrics, logs, and traces. Sorry, can you guys hear me? Just give me a thumbs up or if you guys can see it. So for monitoring, we scrape 3,000 with metrics, logs, and traces. So logs is whatever your application does, it is recorded, right? It's the time too that it's happened. Let's say someone enters the application, so it will record so user enter the application at a certain time, another data as well. Those ones are logs. Then metrics are time series data. It works with time. So let's say an example of a metric we might be measuring is your CPU usage, your server. So that's CPU. So you can say, okay, in the last 5 minutes, or in the last 1 hour, what was my CPU usage level? So you see it, is it 10%, 50%, 80%, or if the capacity it was used up 100%. So the next one is traces. Traces, it's tracing your application from the beginning to end. Like you're trying to, let's say your application shuts down. You use traces to know what happened. You trace it from that beginning side to the ending part of it to know where the error is. Then when you now find out the error, you start working on resolving that particular issue. So I think that's all because my time is almost up. Let's try to fit everything in and rush a bit. So today we walk through the real journey from writing code to testing it, right? And testing it automatically, not just manually. And finally deploying it reliably to the cloud. So to explore how developers, cloud engineers collaborate to build scalable production-ready systems using various tools and monitoring solutions. So The core message is simple. Automation, observability, and an iteration are what turn local projects that you have on your local PC into resilient live applications. So, yeah, I think that's the end of it. So, maybe I don't know if questions can come. Victor.
Okay, okay, okay. You are done, right, Mr. Thank God?
Yes, 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 I'm done.
Okay, okay, okay. That is as you all have had this is how you move a product or a startup or a project from the building phase, its development phase, whereby you put in your code, your programming languages, you set your database, you set all those other stuffs. Down from there down to deployment, whereby you put it in live. You had everything. Is either you can go for the free version, which is Vessel for front end, Render for backend, Cyclic for backend, Netlify for front end, or the paid version, which will give you more servers, more server space, which is AWS and those other terms you mentioned, like Docker, Terraform, that do that. Is that you can is that you do them yourself, like I said, in this tech field, is either you are the front end developer or you are the back end or you are both full stack developer, or when you are moving to the other end, is either you are the cloud engineer. They also have their own fields, which is the DevOps and other fields in cloud. Or it can be a jack of all trades and do all of them. You can do all of them, but it will require you time and enough energy. But then it's up to you. Or you can have enough money to outsource all of them. Then maybe you can do the marketing, you can market the product, and you market it very well, whereby you can get a massive return on capital spend for the product. Okay, right now we will entertain all questions before we move to the giveaway aspect. Let's just entertain all questions. So if you have any question to ask, maybe you want to ask more about the no code development part, or you want to ask about something in the cloud part, you can ask in the comment section, or you can raise your hand. If you can raise your hand, I will let you speak. Then we will answer what you have to say. Let's just do that before we proceed to the giveaway aspect. So I'm waiting. Is there any question? I hope you all can hear me. No questions so far. Okay. So there are no questions so far. Okay, okay, okay. I hope you all can hear me. Just drop a reaction if you can hear me. Okay, okay. 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 I believe. I believe. Wait, give me. Okay. For the giveaway aspect, it's just one simple question right now. Just you can answer in the comment section. Just give me like four tools, whether coding, testing, deployment, whether development or cloud. Just give me four tools that were discussed by any of the speakers. Just four in total. Drop it in the comment section and we pick out the winner. Anyone? Okay, there's one so far. Okay, okay. I believe we keep our giveaway to ourselves. Okay, let's just round up and we call it a day. Um, as you all know, we are a tech training institute that offers various tech courses ranging from data science, data analysis, web development, cloud engineering, cybersecurity, and product design. Um, so right now, we also offer bootcamp. We also do bootcamps whereby we will teach interested persons in tech. We teach them any course of their choice for a what a full fee. So it can be either online or on site, depending on which one suits you. Online has its own price, on site has its own price, but nevertheless, we still give you the same value for both. So if you, peradventure, if you are interested and you want to enroll, you can chat our, you can chat us. You can info us as info at SmartHub Academy, SmartHub hyphen Academy, SmartHub smart hyphen hub dot academy, or you can chat us up any of us in the WhatsApp group, any of the admins, then we will. Okay, okay. Someone has finally answered. Just for testing, VS Code, GitHub, Terraform, and yeah, yeah. Okay, okay, Brian. I will chat you up. Are you in the WhatsApp group? I don't know if you're in the WhatsApp group. Are you in our WhatsApp group or not? Okay, okay. Just chat any of the admins, or you can chat me up. I'm Victor Bona. Just check for Victor Bona, so you can chat me up for the recent giveaway. It's airtime giveaway, so you can chat me up for that. So you got it correctly. So So that is it. We have, and we also have a 1 month tech program coming up, which is for people that okay, they are interested in the bootcamp, but they want to have a sneak peek of what they are going to learn. Like they want to have a sneak peek of tech in general. So we assemble like tech related subtopics from different aspects and put it into you for that period of 1 month. So it's more like a 30 days in tech. If you are that kind of person that oh, you have had this one, 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 you don't know particular which one particularly is for you. So you can just enroll in that experience whereby we will touch everything for you. Then from there you can say, okay, this is what tech is all about, and this is what I want to specialize into. So once you join when we are about to finish. Okay, so that's all. So Brain, just Brian, sorry, just chat me up and I will another person wants to join. It's already late. So thank you everybody. That's all. Okay, sorry, Odin, sorry. The program has ended. Imantech, sorry, the program has ended. We will share, just chat us up, chat any of the admins up on WhatsApp. We will share the recording with you, and we are also dropping it in the group. So we are also dropping the recording in the group. So just be anticipating, or better still, you can chat me up on WhatsApp, so I'll keep you notified when it drops. So that's all. We just finished now. So shit. Okay, Brian, just chat. Brian, can you hear me? Just chat me up. Just chat me up, and Victor Bonner, just chat me up on the WhatsApp group. I believe you're in the WhatsApp group. Nimantech, can you hear me? Just drop a reaction if you can hear me.
Yes, I can hear
Okay.
you, sir.
Okay, what I was saying is that we are done with the webinar. We are done with the webinar. The webinar was from 8 to 9. So we are done. But we recorded this meeting. So